Hello students, welcome to EdViz Learning. My name is Rajendra and I'll be your maths tutor this year along with a few other teachers. Today we'll be starting with 5th chapter, Quadratic Equations from your maths textbook. The textbook that we are going to refer is Concise Selina Publications, correct? So that's the most popular textbook for mathematics, ICSE. We are using the same. We'll start with the chapter Quadratic Equations. The very first thing that you must know is what exactly is a quadratic equation. Now, I know that you had this chapter last year also, correct? So you must already know what it is. I'll just revise it once again. So, you people are aware of the term polynomial, correct? Or you can say an algebraic expression. So, if an algebraic expression with the variable x is written like this, okay, based on the highest power of the variable or the degree of the polynomial, we can say which type of polynomial it is. For example, here the highest power is 1, okay. So, if the highest power of the variable or the degree of the polynomial is 1, we say that it is a linear polynomial, okay. This is a linear polynomial. But when the degree of the polynomial is 2, at that time, when the degree of the polynomial is 2, you can see there are 3 terms, right? But the highest power of the variable is 2. That's why this type of a polynomial is called as quadratic polynomial. Okay. Now, what is the meaning of the word quadratic equation? So, if I just equate a quadratic polynomial with something else, okay, but remember you cannot change the degree of the polynomial. If I just equate this quadratic polynomial, okay, with something else, let us say 0, then it becomes a quadratic equation. Okay, so quadratic equation is nothing but an equation where the highest power of the variable or the degree of the equation is 2. Okay, 2 से कम अगर होगा तो it is a linear polynomial. If more than 2, then it becomes a cubic equation or a cubic polynomial. So what is quadratic equation? If you equate a quadratic polynomial with something else, I'm just writing 0 here. You can write a number also. You can write some other term of x also. But remember, the degree of the polynomial should not change. Highest power should be 2 only. Okay? So that type of an equation is called a quadratic equation. Now the question comes, why do we need such equation? Okay, why do we need quadratic equations? क्या जरूरत पड़ती है? So in your day-to-day life, you might come across some problems which will require the solving of a quadratic equation. Okay, so कैसे problems आते हैं? We can see one example. So for example, you want to buy a piece of land. This is a rectangular piece of land that you need to buy, correct? But the budget that you have is only to buy 300 meter squares of land. Okay, you can buy only 300 meter squares of land. But you should buy it in such a way, it's your condition that I need the piece of land in such a way कि whatever the breadth of this land will be, suppose x meters. Okay, whatever the breadth of this land may be, suppose x meters, the length should be 1 meter more than x and double that, correct? So 2 times x plus 1, okay, 2 times x plus 1 should be the length. Whatever will be the breadth of that, you have to add 1 meter to that and make it 2 times that much. So this is the length, this is the breadth, and this is your piece of land of 300 meter squares area. But the question still remains, ki what should be the breadth then? Okay, how much breadth do I need for this land and what should be the length of this land? So for that, we can form an equation like this using the formula for area of rectangle. You know the formula, it is length multiplied by breadth. Okay, area of rectangle is length multiplied by breadth. Length here is 2 times x plus 1, and if you multiply with this breadth, which is just x, you observe that area is something which is already known to us in this condition because मुझे पता है कि I need to buy 300 meter squares of land, correct? So 300 should be equal to, okay, length multiplied by breadth. So x into 2, 2x, 2x into x becomes 2x square plus 2x into 1 becomes 2x. Okay, so this is the equation, quadratic equation. It is a quadratic equation because you can see the highest degree, highest power of the variable is 2, correct? So this is a quadratic equation. So if you need to write it in a proper way, in a standard format, you can write it like this: 2x square plus 2x minus 300 equal to 0. Okay, this is the standard way of writing a quadratic equation. क्या है ये way? We will discuss now. So 2x square plus 2x minus 300 equal to 0. So remember, the standard form of a quadratic equation is always like this: ax square plus bx plus c equal to 0. Okay, in this equation, the variable is x and a, b, c are nothing but constants, correct? A, b, c are nothing but constants. So I have this equation with me right now. If I solve it, I will get some value of x. If I get the value of x, I know ki breadth should be this much, and based on that, I can find out the length also. Okay, so that is just an example, a real life example where we can use quadratic equations. There are many such examples given to you in the last exercise of your chapter. We will discuss them when we come there. Now let us discuss the standard form in a little bit detail, correct? As I told you, the standard form of writing a quadratic equation is ax square plus bx plus c equal to 0, where the variable is x and a, b, c are constants. But there is one more thing here that you must remember, that a cannot be equal to 0, where a is not equal to 0. Why it is not equal to 0? Because if a is equal to 0, it's not a quadratic equation at all. A becomes 0, this entire term becomes 0, and the remaining part is just a linear equation. Okay? So if it is a quadratic equation, a cannot be equal to 0. Highest power should be 2. Okay? Only then it is a quadratic equation. Now this is the standard form of writing a quadratic equation. There is one more thing here that you must know. There is something called as discriminant. Okay, discriminant of a quadratic equation. Now what is discriminant? So it depends on the values of a, b and c. Okay, discriminant is nothing but, formula for discriminant is b square minus 4ac, where a, b, c are the constants that you see here in the quadratic equation. So for example, I have a quadratic equation 2x square plus x minus 4 equal to 0. Okay, here a is the coefficient of x square, that is 2, b is the coefficient of x, that is 1, c is the coefficient or the constant term here, that is minus 4. Remember, you have to consider it along with its sign, because in the standard form they are all positive. So if c, the value of c I need to write, it will be minus 4 along with the sign. So a, b, c, just put it here and you will get the value of discriminant. Now the question is, क्यों चाहिए मुझे discriminant? Why do we need it? So discriminant, as the name suggests, it helps us to understand that what type of solution our quadratic equation will have. ठीक है, quadratic equation का जो solution हम लोग find out करने वाले हैं, what type of solution it is going to be. So इसके बारे में we will discuss a little bit more in detail in the upcoming exercises. But first, you must know that this is the standard form of a quadratic equation, and a, b, c are constants where x is the variable, and a should not be equal to 0. Okay. Now, we are not going to immediately start solving the quadratic equations, correct? Solving part will come a little bit ahead. For now, let us just try to understand something called as roots of a quadratic equation. Okay. Now, the word roots just means the solution of the quadratic equation. We are not finding out the solution, but we can check whether a value, a particular constant, it is a solution of this quadratic equation or not. For example, in the same quadratic equation, 2x square plus x minus 4 equal to 0. Okay. If I need to check whether x equal to 1, it is a root of this quadratic equation or not. So all you have to do is substitute 1 instead of x in the equation, or the left side at least, and you have to check whether the value that you are getting, it is equal to the right hand side or not. So in this equation, if you put 1 and the answer that you get is 0, then it is satisfying the equation. If not, it's not satisfying the equation. Correct? So if it satisfies the equation, x equal to 1 is called as the root of the quadratic equation. So here, let us check whether this is a root or not. Substituting x equal to 1 in the equation. So therefore, you get 2 times 1 square plus 1 minus 4. Correct? Let us now check what the answer is. This will be equal to 2 plus 1 minus 4, that is minus 1. Now it is minus 1, but we need it to be 0. Okay. So since it is not equal to 0, this is not a root. Okay. Root kab hoga? If we get the value as 0. Correct. Then we can say that it is the root of this quadratic equation. So these are the roots of the quadratic equation. Now let us go to the very first exercise we have here. Exercise 5a in your textbook. Okay, the first question has a lot of sub questions. I'll just read it. Find which of the following equations are quadratic. Okay, the first question is find which of the following equations are quadratic equation. The very first equation here is 3x minus 1 the whole square equal to 5 into x plus 8. We have to tell them whether this is a quadratic equation or not. So try to bring the equation to its standard form. After that, we can check whether the degree is still 2 or not. Okay, here if I just solve this equation, we open this bracket using the identity a minus b the whole square. Correct? So a minus b the whole square, you know it is a square, that is 3x square, minus 2 times ab, that is 2 into 3x into 1, plus b square, that is 1 square. This becomes the left hand side of the equation. On the right side, if I just multiply 5 here, it will become 5x plus 5 8s are 40. Okay. So the equation here is 9x square minus 6x plus 1, and if we bring these two terms on the left side, minus 5x minus 40 equal to 0. Okay. Simplify it further. 9x square minus 6x minus 5x will become minus 11x, and plus 1 minus 40 will become minus 39 equal to 0. Now this is clearly a quadratic equation. You can see the highest power is 2, the degree of the equation is 2. Therefore, it is a quadratic equation. Okay, this is a quadratic equation. Similarly, we'll have to check for the second one also. 5x square minus 8x equal to minus 3 multiplied by 7 minus 2x. Correct? The equation is this. 5x square minus 8x equal to minus 3 multiplied by 7 minus 2x. Now in this equation, you don't even need to simplify it. Why? Because there is no other term like 5x square, no other like terms. It will not get eliminated or cancelled out. That's why this is going to stay the highest power of the equation. Correct? So it is a quadratic equation. You can directly write down. Correct? It is a quadratic equation. You can say that directly. Similarly, third one, if we solve it, the left hand side is x minus 4 multiplied by 3x plus 1 equal to, right hand side is 3x minus 1 multiplied by x plus 2. So let us check whether upon solving it is a quadratic equation or not. Open the brackets. X multiplied by 3x plus 1 minus 4 multiplied by 3x plus 1 equal to 3x multiplied by x plus 2 minus 1 multiplied by x plus 2. Okay, so this will become 3x square plus 1 into x is x minus 4 3s are 12x minus 4 into plus 1 is minus 4. Again here we have 3x square plus 2 3s are 6x, correct, minus x minus 2. Now if you bring each and every term on the same side, you will get 3x square as it is plus x minus 12x. So minus 11x as it is, minus 4 as it is, and all these terms we will shift on the left side. So minus 3x square minus plus 6x minus x will become plus 5x. On this side it will become minus 5x, and minus 2 finally will become plus 2 equal to 0. But in this equation, even though there is a term with highest power 2, you can see that this is getting cancelled, correct? 3x square minus 3x square is getting cancelled out, and the remaining equation is just a linear equation. Since the degree of the equation is now 1, it is not a quadratic equation. Okay, since the degree of the resulting equation is 1, it is not a quadratic equation. Okay, so that's it then. I'll just give you some time to note this down, then we'll move on to the next question. Alright students, let's go to the next sum now. Fourth one, the fourth sub question here. Let us check whether that is a quadratic equation or not. The question is x square plus 5x minus 5 equals to x minus 3 the whole square. Now if you solve this, you will find out that even this is not a quadratic equation. How? Let us check. X square plus 5x minus 5, if I keep it as it is, this will be equal to a minus b the whole square identity. So x square minus 6x plus 3 square, that is 9. Correct? Once again, if you bring the terms on the left hand side, x square plus 5x minus 5 minus x square minus 6x minus 9 equal to 0. Okay, so minus 6x will now become plus 6x. So that there will be a sign change, but once again x square minus x square, it is getting eliminated, and the resulting equation once again is a linear equation. That's why we can say that this is not a quadratic equation, since the degree of the resulting equation is 1, it is not a quadratic equation. Okay, so once again we have a equation which is not quadratic. Fifth one. Now fifth one, the question is 7x cube minus 2x square plus 10 equal to 2x minus 5 the whole square. So even if you solve this further, the highest power is still going to be 3, correct? 7x cube, because there is no other like term. and even if you solve the right hand side, there is no term with cube in it. Okay, so fifth one you can directly say, since it is a cubic equation, it is not a quadratic equation, correct? The highest power is 3, the degree of the equation is 3, so it is not a quadratic equation. Then we have the last sub question, sixth one, which we will check whether it is a quadratic equation or not. Let me just write the question here. X minus 1 the whole square plus x plus 2 the whole square plus 3 times x plus 1 equal to 0. Okay, this is the last sub question that we have here. Let us solve this quickly. So this will be equal to, use a minus b the whole square once again. So x square minus 2x plus 1, and once again the same formula, x square plus 4x plus 4, and then multiply 3 inside the bracket, it will become 3x plus 3 equal to 0. Correct? Now in this equation, x square and x square is getting added, it's not getting cancelled. So we have 2 times x square minus 2x plus 4x and plus 3x will become plus 5x. Okay, minus 2 plus 4 plus 2 plus 2 plus 3 will become plus 5. So plus 5x. Then 1 plus 4 plus 3, we have 8 here equal to 0. And now clearly we are getting a quadratic equation. So we will say that it is a quadratic equation. Therefore, it is a quadratic equation. Okay, with this we are done with the first question in this exercise. Once again, I'll give you 1 minute to note this down, then we'll move on to the next question. Let's continue, students. Next is question number 2. Okay, so let's go to the second question here. Question number 2, is x equal to 5 a solution of the equation x square minus 2x minus 15? So we have an equation here, first sub question, x square minus 2x minus 15 equal to 0. This is the equation that is given, and we have to check whether x equal to 5 is a solution or not. Okay, check x equal to 5, whether it is a solution or not. So you have to substitute x equal to 5 inside this equation. If you get 0 as the value, which is equal to the right hand side, we can say it is a solution or a root of this quadratic equation. Don't forget this word, correct? So let us check, substituting x equal to 5 on the left hand side of the equation. Okay, so the left hand side will become equal to 5 square minus 2 into 5 minus 15. So wherever there was x, I just wrote 5. We are checking whether this is equal to 0. Let's see, 25 minus 10 minus 15. Now 25 minus 10 is 15, 15 minus 15 is 0. That means it is satisfying the equation, which makes it a solution of this equation, correct? So therefore x equal to 5 is a solution, or you can use the word root of this equation. But don't forget, we have not yet arrived to the part where we solve a quadratic equation. So don't think that this is the only solution for this equation. Every quadratic equation can have at max 2 values, at most 2 values, correct? So this is just one of those values. There might be some other value as well. We will come to that later, but for now, this is what you need to understand. Let us go to the second sub question here. We have one more sub question here, question number 2, second one. Okay. In this question, we have to check whether x equal to minus 3 is a solution of the equation 2x square minus 7x plus 9 equal to 0. Okay, we have to check for x equal to minus 3. So substituting x equal to minus 3 in the left hand side of the equation. So your left hand side will become equal to 2 times x square, means 2 times minus 3 square, minus 7 multiplied by minus 3 plus 9. So this is equal to 2 times minus 3 square is positive 9, okay, and minus 7 into minus 3 is also positive 21. So you are getting 18 plus 30, that is 48. Now this is clearly not equal to 0 or clearly not equal to the right hand side. Okay, so we can say that x equal to 3 is not a solution of this quadratic equation. Therefore, x equal to minus 3 is not a solution of this equation or quadratic equation, whatever you want to write. Correct? So this is question number 2 done. I will give you 2 minutes to note this down. Then we'll go to the next question. Alright students, moving on to the third question in the exercise. Let me just change the page here. I hope you are done writing. Now question number 3. In this question, root 2 upon 3 is a solution of equation 3x square plus mx plus 2 equal to 0. Okay, so the equation here is 3x square plus mx plus 2 equal to 0. In this equation, they have told us already that square root of 2 upon 3 is a solution. But we have to find the value of m. As you can see in this quadratic equation, only 2 of the constants are given, 3 and 2, a and c. But we don't know the coefficient of x, that is m. That is what we need to find out based on the information that root 2 upon 3 is a solution of this quadratic equation. Now, the plus point of this information is that we already know कि if I substitute root 2 upon 3 instead of x in this equation, it is going to satisfy it, because question में पहले ही बोल दिया है कि it is a solution, right? So we can directly substitute inside the equation. There is no need for LHS RHS. That was just for checking. But now we already know it is a solution. We can directly substituting x equal to square root of 2 upon 3 in the quadratic equation. Okay, we are substituting it directly in the equation. So therefore 3 times square root of 2 upon 3 square, x square is square root of 2 upon 3 square plus m multiplied by square root of 2 upon 3 plus 2 equal to 0. Okay, now if you look at this equation, here only one variable m is there which we need to find out. Okay, x ki jagah pe we have substituted root 2 upon 3 because we know it is a solution, right? So let us solve this. 3 multiplied by root 2 square is just 2. I hope you know this, correct? If there is a square root and then also a square, the number under the square root itself is the answer. So root 2 square will get 2, root 3 square also we will get 3, correct? Plus m root 2 upon 3 plus 2. Here you can see 3 and 3 is getting cancelled. This 2 and this 2, they will get added. So you are getting m multiplied by root 2 upon 3 plus 2 plus 2 is 4 equal to 0. We need the value of m, so we will send everything else on the other side. So m root 2 upon 3 will be equal to minus 4, correct? Since plus 4 on the other side will become minus 4. After this, the value of m will be equal to minus 4 multiplied by root 3 upon 2. It will become reciprocal when it goes on the other side. Okay, so this will be equal to minus 4 multiplied by root 3 divided by root 2. But always remember, whenever you write the final answer for a question like this, the denominator should never be irrational. Okay, so what we will do here is multiply and divide by root 2. Okay, so this will become equal to minus 4 multiplied by root 3 into root 2 will become root 6 divided by root 2 into root 2 will become just 2, correct? So 2 ones are 2 twos are 4. The final answer is minus 2 root 6. This is the value of m. Okay, so the value of m in this equation is minus 2 root 6. I hope you understood the question. I'll give you 2 minutes to note this down, then we'll move on to the next question. let us continue. Now moving on to the fourth question in the textbook. 2 upon 3 and 1 are the solutions of equation mx square plus nx plus 6 equal to 0. Find the values of m and n. So this time we have to find two values. Okay, the equation that is given to you in the textbook in the fourth question is mx square plus nx plus 6 equal to 0. Okay, but this time for this equation they have given us both the solutions already in the question. Okay, both the solutions of this equation are given to us. The first solution is 2 upon 3 and the second solution is 1. Okay, so 2 upon 3 and 1 are the solutions of this equation. We have to find the value of m and n. Now to solve this equation, what we will do is, first we will substitute 2 upon 3 in this equation. Okay, let us see what we get. Substituting x equal to 2 upon 3. So the equation will become m multiplied by 2 upon 3 square plus n multiplied by 2 upon 3 plus 6 equal to 0. Correct? Now 4 upon 9. 2 square is 4, 3 square is 9. So 4 upon 9 m, okay, plus 2 upon 3 n plus 6 equal to 0. Okay, we will simplify this equation a little bit. You can see the LCM of 9, 3 and 1 is 9. So this will stay as it is. Here we will have to multiply the denominator by 3. So the numerator also gets multiplied by 3. It will become 6n plus 1 multiplies with 9 because the LCM is 9. So 6 multiplied by 9, 54 is the numerator. So this becomes my equation. This 9, when it goes on the other side, okay, it will become equal to 0. So our equation is 4m plus 6n plus 54 equal to 0. Okay, we are trying to bring it to a linear equation. We are just making it a linear equation in two variables. Okay, now this entire equation is divisible by 2. We can eliminate that. Okay, divide it by 2. So dividing equation by 2. So what will this equation now become? If we divide it by 2, 4m will become 2m, 6n will become 3n and 54 will become 27. Take 27 also on the other side. Your equation is 2m plus 3n equal to minus 27. This is the first equation that we get. Okay, remember we need to find m and n both. To find both, we will need two equations. So first equation we got by substituting 2 upon 3 in the quadratic equation. How will we get the second equation? So for that we have one more solution of this equation, that is 1. Now we will substitute x equal to 1 in the quadratic equation. Now substituting x equal to 1 in the quadratic equation. So it will become m into 1 square plus n into 1 plus 6 equal to 0. That means m plus n equal to minus 6. This becomes my second quadratic equation. So let us now solve this equation by substitution method. I hope you remember what substitution method is. You have studied it in your 9th standard. You have two linear equations with two variables. There are multiple ways we can solve them. Okay, one of those methods is substitution method. So let us use that. Okay, so here from this equation you can say that n is equal to minus 6 minus m. What I have done is shifted plus m on the other side, which gave me the value of n, that is minus 6 minus m. Now we will put this in the first equation. Instead of n, what we will write? Minus 6 minus m in the first equation. So substituting n equal to minus 6 minus m in equation 1. So it will become, first equation will now become 2m plus 3 times, instead of n I will write minus 6 minus m, okay, equal to minus 27. So now in this entire equation there is just one variable m that we need to find out. Let us do that. 2m, so minus 18, 3 into minus 6, and minus 3m, because this is negative, will be equal to minus 27. 2m minus 3m, we know it will be minus m, okay, and minus 18 on the other side will become plus 18, so minus 27. So we are getting minus m equal to minus 9. So what will be the value of m? M is just positive 9, correct? M is, therefore, m is equal to positive 9. Now we have the value of m, all we need to do is find the value of n. So in this substitution, we found the value of n in terms of m, okay. So instead of m, now we will just substitute 9. Therefore, we know that n is equal to minus 6 minus m. Here we will substitute minus 9. So it will become equal to minus 15. This is the value of n. So m is 9, n is 15. That is the solution of this question. With this, we are done with the fourth question in the exercise. Now the fifth question, if you look at the question, is just similar to this question, okay. If 3 and minus 3 are the solutions of equation ax square plus bx minus 9 equal to 0, find the values of a and b. It is exactly the same question as this. So I want you to solve question number 5 of this exercise as homework, which completes the exercise for us. Now to note this down, I will give you 2 minutes, then we will conclude the session. Okay students, I hope you understood today's session. We just introduced quadratic equations. Okay, we haven't yet gotten to solving them. So in the next lecture, we will start with the remaining part of this chapter. Till that time, please complete your homework and revise what we have done today. Thank you everyone.